All right, so the reason I stopped is because on the second page we have a different type of equation. So on the other side of the paper we had radicals on one side, but now if you look at these ones in number 9, there are radicals on both sides. So here's how we do this. We want to raise both sides to the same number. So if both radicals have the same index, that's good. If they don't, then we're in trouble. But all of these will have the same index. So what we want to do is we're skipping step number 1. The short of it is we cannot isolate the radical because there's one on every side. So we're going to skip number 1 and just go straight to number 2, raise each side of the equation to the power of the index. So in number 9, we're just going to raise each side to the second power since our index is 2 to get rid of the radicals, okay? So now all that's left is because I raised it to the power of the index, the radicals go away. So I have u minus 8 equals 43 minus 2u. And then we just solve. We solve it like a regular equation. So I think it's going to be easier to add 2u. So u plus 2u is 3u minus 8 equals 43. I'm going to add 8. 3u equals 51. Divide by 3. U equals, in case you didn't know, 51 divided by 3 is 17. But what do we have to do now? We have to check to make sure it works. So check. By plugging 17 in for u in both sides. Okay. So we plug it in and we have to check to make sure that we get a good answer. So 17 minus 8 is 9. 43 minus 2 times 17 is 34, in case you didn't know that. So square root of 9 equals 43 minus 34 is also 9. Square root of 9 equals square root of 9. We're good. As soon as you get the same thing on both sides of the equation, you know you're golden. Okay? So let's do number 11. All right, so this time we have numbers in front of both radicals. You're not going to be able to get rid of them, but you can move them all to one side. So what I'm going to do is, since I know 12 is divisible by 4, I'm going to divide both sides of the equation by 4 to move all the numbers onto one side. So all I have left on the left is radical 3q plus 15 equals 12 divided by 4 is 3, square root of q. Okay, I cannot isolate the radicals, which we know that already, so I'm going to raise both sides to the same power, which is 2. Now here's where a lot of people get messed up, is they will only raise the radicals to the square root to 2. But you need to raise everything to the square root, or not to the square root, to 2 power. Because you cannot just pick and choose what you square. You have to square everything. So when I taught this last year, a lot of people made this mistake and didn't square the number. You want to make sure you square the number in front as well. Don't just pick and choose. You have to do everything. So let's see what happens. This got rid of the radical, so we have 3q plus 15 equals 3 squared is 9. The square took away the square root, so we have 9q. Okay? So that's what this did over here. So now we solve. Minus 3q. So 15 equals 6q. Divide by 6. Divide by 6. Q equals, well, they can both be divided by 3. So 15 divided by 3 is 5. 6 divided by 3 is 2. So Q equals 5 halves. Well, let's see. We have to check to make sure it works. Okay, we're going to plug 5 halves in for Q to the very original. 3 times 5 halves plus 15. 12 times square root of 5 halves. Okay, So let's figure out this one. 3 times 5 halves plus 15. Well, 3 times 5 is 15, so this is going to be 15 over 2 plus 15. We're not going to change the right side at all. It's going to stay the same throughout the whole thing. Okay, so if I add these two together, common denominator is 2. So 2, to make this over 2, I have to multiply bottom and top. So this becomes 30 over 2 plus 15 over 2 is 45 over 2. Okay, I know 45, to make this easier on myself, is 9 times 5. I'm going to show you where I'm going with this. What's the square root of 9? 3. 3 times 4 is 12. Times the square root of 5 over 2. Oh, look at that. We get the same thing on both sides, so it works. Okay, don't get caught up on what I just did because this involved a lot of fractions and moving things around. The main idea is you want both sides of the equations to be the same. What you could do is you could plug this in the calculator, get a number, plug this in the calculator, and you better hope it's the same number as that. Okay, so that's the easy cheater way basically to do it. Okay, number 13, just to move it along here. We're going to square both sides. This one only has a radical on one side, but it's okay. We're still going to square it because the index is 2. So what this does is this gets rid of the radical. I have 8x equals x squared. So this is a quadratic. I need to get all the x's on one side. So I'm going to subtract 8x. Get 0 equals x squared minus 8x. I can factor this. They both have an x in common. So I'm going to factor out an x. And what's left is x minus 8. Okay, so this is unit 1 stuff. And then what I do is I set both of these equal to 0. So x equals 0, x minus 8 equals 0. So x equals 0 and x equals 8. You guessed it, we have to check both of these. You cannot just check one, you have to check both. So since 0 is easy, let's do 0 first. It's not 80, it's 8 times 0. 8 times 0 is 0. Square root of 0 is 0, so that works. Okay, so now let's check 8. Eight times 8 is 64. The square root of 64 is 8. 8 equals 8. And we're good. They both work. That's nice. Okay, we have 2 more and we'll be done soon. Okay. Radicals on one side by itself. Index is 2. Square both sides. 6m minus 38 equals, do not distribute this square. I'm telling you, don't do it. This is m minus 5 times m minus 5. That's what that says. So we have to FOIL. M times m is m squared. So what's going to happen is you're going to have minus 5m, which is minus 10m, because you're going to have minus 5m, minus 5m. Combine them, you get minus 10m. And then minus times minus is plus. 5 times 5 is 25. So another quadratic, I need to move everything over to one side. So I'm going to make this side 0. I'm going to subtract 6m. So I get m squared minus 16m. And I'm going to end up adding 38. So it's 25 plus 38 is 63. So I need to find two numbers that multiply to negative 16 and add to 63. They're both going to be negative. If you said 9 and 7, you are correct. So m equals 9, m equals 7. We have to check to make sure they both work. So we'll check 9 first. Equals 9 minus 5. 6 times 9 is 54. 54 minus 38 is 16. Square root of 16 is 4. 9 minus 5 is 4, so that one works. And let's check 7. Six times 7 is 42. 42 minus 38 should be 4. Square root of 4 is 2. 7 minus 5 is 2. They both work. Okay, we have one more. So you guessed it, we are going to raise both sides to the second power because our index is 2. All right, so I get 51 minus 5y equals, I'm not going to distribute the square, I'm going to FOIL. Y times y is y squared. I'm going to get minus 11y, which makes negative 22y, plus 11 times 11 is 121. And I'm going to move everything over to one side. So I'm going to end up adding 5y. So that's going to give me negative 17y. And I'm going to subtract 51. 121 minus 51 is 70. So I need two numbers that multiply to positive 70 and add to negative 17. Hopefully you thought 7 and 10. So y equals 7, y equals 10. Check to make sure. Let's do 7 first. Okay, 51. So 5 times 7 is 35. 51 minus 35 is 16. So square root of 16. 7 minus 11 is negative 4. So when you take the square root of a number, you only want the positive square root. So this would be 4 does not equal negative 4. So 7 does not work. So let's try 10. Let's see if we get anything good from 10. Five times 10 is 50. 51 minus 50 is 1. 10 minus 11 is negative 1. The square root of 1 is 1. It does not equal negative 1. So this one doesn't work either. So this one has no solution. No solution. Okay, so this is a long video, so I'm going to save the rest of them for in class. I hope you try these at home. So this was concept number 4.